All right. So today we are talking about solving exponential and logarithmic equations. So think about what we're doing. I'm solving. So what does that mean? What does solving mean? Because there's a difference. If I say evaluate, that means that there's no x. It's just telling me what it is. Solving means that there is an x and I want to know what it is, right? Okay, so um, we've already worked with these two things, exponential equations. What makes an exponential equation an exponential equation? So an exponential equation obviously has an exponent, but more specifically, the variable is the exponent, right? So there's a variable in your exponent. So like for instance, x squared, would that be considered exponential? No, it has an exponent, but the variable is not the exponent. Does that make sense? Okay? But if I had 2 to the x power, would that be considered exponential? Yes, because now the variable is my exponent. That's the difference, okay? And then of course, logarithmic equations are equations that have logarithms, duh, of variable expressions, okay? So they have log of something, of an x, okay? All right, so let's kind of review a little bit. You already know this. You already know this. If b is a positive number other than 1 and b to the x equals b to the y, we already know this. If my bases are the same, what happens? They don't cancel. You just ignore them, and essentially your exponents are equal to each other, correct? Like if I gave you this, 3 to the x power equals 3 to the 5th power, then what do you know for sure? X equals 5. Does everybody remember that? Okay, so let's do a couple of review problems just to make sure we understand what we're doing. Okay, so that was the review. You already know. You already wrote it down. So here we go. I have 4 to the x power equals 16. I got 4 to the x power equals 16. Okay, do you guys remember what we did? So you try and rewrite one side or something, right? Try and rewrite it in the same base. So the question is, 4 to what power is 16? So then I have to rewrite my equation. My equation is now going to say 4 to the x power equals what? 4 squared. Okay? 4 to the x power equals 4 to the second power. Now what? Now that my bases are the same, you just ignore them, and I have a new equation with just my exponents, and it would be equal to what? X equals 2. You guys remember that? We good with that? That was from the lesson before last. So the last lesson was the whole switching exponentials to logarithms and all that. Remember that? So here I go. What about the next one? So say I have 2 to the x plus 1 equals 8. 2 to the x plus 1 equals 8. So what am I going to try and do here? Good. So David says 2 to the third power is 8. So I can rewrite this as 2 to the x plus 1 equals 2 to the third. Agreed? Now what? So it's just x plus 1 equals 3. So x equals 2. Any questions? We were all good with that, right? We were all good with that, okay? So let's kick it up a little notch. So say we had something like this. 9 to the 2x power equals 27 to the x minus 1 power. So 9 to the 2x power equals 27 to the x minus 1 power. Is there a problem here with this one? Good. So Tiana said, look, I can't make 27 a base 9, right? Because 9 squared is already 81, so that's too big. So she's saying, okay, well, can I change both of them? And of course the answer is, yeah, I can change them both to the same base. What base do they have in common? So 9 is really what? 3 squared, but again, it's still to the 2x power. And 27 is really what? 3 to the third, and it's still to the x minus 1 power. So something interesting happened on these. I actually have an exponent raised to another exponent. And what do I do when I have an exponent raised to another exponent? you multiply them, right? So like for instance on the left side, it's just straight multiplication. So this really is 3 to the 4x. And on the left side, on the right side, sorry, it's 3 times x minus 1, which turns into what? Good, it's more like distribution. So it's going to be 3 to the 3x minus 3. You guys good with that? Right? And then at this point, ignore the bases and set my exponents equal to each other. Now, guys, what do I do when I have x's on both sides? You move them together on one side. Does it matter which one you move to the other? Absolutely not. Does not matter. However, I told you, which one should you move? What's easier? Move the smaller one, right? Move the smaller one. That way you probably don't have to deal with negatives. Good. So I would subtract 3x, right? So then that would give me x equals negative 3. We good with that? Any questions? Okay, before we move on, why don't y'all try part D on your own? Okay, I'm going to give you a little time. Try it. See if we make sure we understand before we move on. All right, so what happened, or what do we do? Good, we change them both to base 10. 100 is really what? 10 squared to the 7x plus 1. And 1,000 is really what? 10 cubed to the 3x minus 2. And then it's exactly like the last one. I'm basically going to distribute. So I get 10 to the what? 14x plus 2 equals 10 to the 9x minus 6. So again, bases are the same. So I have 14x plus 2 equals 9x minus 6. Now what? Subtract 9x from both sides, which would give me what? 5x plus 2 equals negative 6. And then what? Subtract 2 from both sides. I'm trying to get this alone, so I got to get rid of the plus 2. So I'm going to subtract 2 from both sides. So I have 5x equals negative 8. And then finally, so x equals negative 8 over 5. Can I get a fraction as an answer? Yeah, it's a number, as long as I did the math right. No problem. I should try and reduce it if I can, but in this case I can't. Any questions? So we talked about this when we first learned it, and there was a question that popped up. And does anybody remember that? A very important question. Good. What if, not only if they're not equal to each other, because they weren't equal to each other here, but what if I couldn't get my bases to match, right? Because obviously that's going to happen, right? There's going to be times where I'm not going to be able to get my bases to match, right? So that's what we're basically learning today. What if I can't match my bases? So say I had this equation. 4 to the x power equals 11. 4 to the x power equals 11. Okay? So, does everybody see that it's impossible for me to turn 11 into base 4? Right? Because 4 to no power, or at least no power that I can think of, is 11. Does everybody agree with that? Okay, so that's the problem. I can't change 11 to base 4. Okay? So, what do I do? Well, remember, we learned this 2 lessons ago. Not the last one, the one before. Because I wanted to introduce logarithms. What did I tell you about exponentials and logarithms? They're inverses, right? So they're and sometimes they're actually the same thing, right? So they are involved with each other. So I have this exponential equation, and I can't change the base. So what I'm going to do is I'm going to use a logarithm, okay? So what I'm going to do is I'm going to take log base 4 of both sides. So what that looks like is this. Log base 4 of 4 to the x power equals log base 4 of 11. So I'm going to take log base 4 of both sides. Why? Because in our last lesson, you got 4 properties of logarithms. Do you remember those 4 properties of logarithms? Okay? And one of them said that if a logarithm had an exponent and the bases of those numbers were the same, they cancel out. So, does that benefit me here? Yes, because look what's going to happen. Log base 4 of 4 basically are going to cancel out, right? They're going to cancel out, and I'm left with just what? X equals log base 4 of 11. Good. So she said, look, guys, is it always going to be log base 4? No, it's going to be log base whatever I need to get rid of that other base. Does that make sense? Like if this was 8 to the x power, then I would have taken a what? Log base 8 of both sides. Does that make sense? So whatever base you need to get rid of, that's of an exponent, that's the log base that you'll take. Good? Now, so here's the problem though. If I tell you, oh, x is equal to log base 4 of 11, that doesn't make sense. That's not really a number, right? So I want to actually find out what that really is. So in walks your calculator, okay? In walks your calculator. Do we have a logarithm function on the calculator? Yeah, we talked about it. Where is it? Next to 7. What's the problem though with that one? That is log base 10. And I need log base what? 4. Well, lucky you that you don't live in my era, because back in my day we had to do another step. But because these things are basic computers, someone updated the software for you, and it's very simple now to take a logarithm of any base. Here's how you do it. Alpha window. Now look at that list. See number 5? You're going to press number 5 and then look. It sets you up with a logarithm. You can put any base of any number. So I need log base 4 of 11, not 111. So log base 4 of 11, press enter, bam. Okay, now, so obviously I want you to round, and because this is pre-calculus, on the calculus AP test, we always round to 3 decimal places. So from now on, guys, unless I otherwise tell you, we're always going to round to 3 decimal places. All right? So this is a silly question. Do you guys remember how to round? So if I want 3 decimal places, you go to the 3rd decimal place, which in this case is a 9, right? Look at the next number. If that number is 5 or bigger, your number goes up. If this number is 4 or smaller, your number stays the same. So in our case, 1.729, because of this 7, is actually going to turn into what? 1.30, okay? So I have x, and then I'm going to change my symbol to 1.730. What symbol is this? Approximately, right? It's the same thing, approximately. What's the difference between equal and approximately? So equal means this is this, right? They are exactly the same. Approximately basically means I rounded, right? Because is that really the real answer? No, and even the calculator is not giving you the real answer, because the calculator only rounds to 9 decimal places. So this is actually continues to go on forever, but the calculator says, I'm not going to give you all that. I'll cut you off at 9 decimal places. Okay? So that's why I'm going to change my symbol to x is approximately 1.730. So what does this represent, people? This represents my exponent. So do this for me in your calculator. What's 4 to the 1.730 power? What's 4 to the 1.730 power? You get 11.004. So is that accurate? Yeah. Obviously it's not equal. Why? Because I rounded. No, I'm just showing you why we're doing that, okay? So that's what we're finding. We're finding my exponent. Okay? How did I do it? Tell me. Recap. Good. So if you can't change your bases, guys, you're going to take the log base whatever you need so that you can do what you got to do. Any questions? Good. Alpha window number 5. Make sure you understand that. All right, let's try another one. Okay, I have 7 to the 9x power equals 15 this time. I have 7 to the 9x power equals 15. Problem? What? I can't match my bases, right? 7 can't become a 15 anyway. So then what do you think I should do? Good. So it's going to look like log base 7 of 7 to the 9x equals log base 7 of 15. What's going to happen? The log base 7 and the 7 cancel, so I'm left with what? 9x equals log base 7 of 15. So this one's a little different. Why? Because it's not x, it's 9x. But I know how to fix that. What am I going to do? Divide by 9. Now, here's the thing. I don't want you to put this in the calculator yet. Okay? You're not going to put this in the calculator yet because you're going to have to estimate, right? You're going to have to estimate. Guys, you never want to estimate until the end of the problem. Okay? So don't in the middle of your... Because whatever I'm going to do, if I put it in the calculator, I'm going to get an answer, right? That I'm going to estimate, and then I'm going to have to divide that by 9. You see the problem? So you're estimating in the middle of your work. Does that make sense to you? So, and it's going to look weird, but guess what I'm going to do? I'm going to say x is log base 7 of 15 divided by 9. Now, it looks weird to you, but don't worry, you're not going to do it. The calculator is. And the calculator can handle that. Okay? So, how do you think I should put that in my calculator? So I'm going to set up a what? A fraction. You guys know how to set up a fraction? How? Alpha y equals number 1. And then I can say alpha window number 5. And it's log base, what was it again? 7 of 15 divided. So for the fraction, alpha y equals number 1, the first one. So you can just press alpha y equals enter. So, looks weird, but don't worry, the calculator will do it. We good? So everybody get that? So x is what? Equals? X is equal to that? X is approximately what? Because isn't there a 4/6? Is it right? So it becomes 0.155. We good? We good? Any questions? Are you sure? Okay, so here's the hard one. So, write it down first. Write it down first. That's how you start any problem, right? Write it down first. Okay, so I have 4 to the e of negative 0.3x minus 7 equals 13. First of all, I threw an e in there. Is that another variable, by the way? No, it's a what? It's a number. It's a number. Okay, so don't think that you're going to solve for e. I never want to see e equals anything because I already know what e is. It's a number. Okay, so ideas. Tell me, what do you think we should do? Remember, I'm trying to solve for x. And solve means always get x by itself. Yes, we can. So let's get rid of anything that doesn't have my x. So I'm going to get rid of this 7, right? So I'll have 4e to the negative 0.3x equals to what? 20. We good with that? So, 1 second. We good? What else do you think? So, not yet. I need this alone. What are they doing? They're multiplying. So I'm going to divide by 4. I have to leave the e because it's the thing with my exponent. You see what I'm saying? So I'm going to just divide by 4. So it'll be e to the negative 0.3x equals 5. Now you with me? So now, Michaela had a good idea. She said, well, I mean, aren't I just going to take a log with a base e, right? I mean, that's what I told you to do, right? No matter what the base is, take the logarithm of base e. Everybody agree with that? However, I told you when we first introduced that is there a logarithm that is automatically base e? What is it called? Remember your ln? Remember, ln, which is called the natural log, is always base e. It is always base e. So I'm not going to take a logarithm of e. It is going to be, you will get the same answer. I promise you get the same answer, right? But the natural log and e always just they're a couple. They always go together, okay? Okay? So, I'm actually going to take the natural log of both sides. Because remember, whatever I do to one side, I have to do the other. Right? So now, what's going to happen to these? They're going to cancel because this has base e and this is base e. So when you take a logarithm of the same base, they will cancel. So here's what I have. Negative 0.3x equals to the natural log of 5. And then what do you think I'm going to do? By what? So the natural log of 5 divided by negative 0.3. So let's go to our calculator. And does everybody know where my natural log button is? Right here next to number 4. Right? So it's going to be, again, how am I going to do this, do you think? Set up a fraction. Natural log of 5 divided by, was it negative 0.3, right? Right? Press enter. Bam. Okay? Did everybody get the right answer? How did I what? I just pressed the ln button. So x is approximately what? Negative 5.365. Any questions? Any questions? So what do I do if I can't change my bases? If I can't match my bases? I'm going to use logarithms. Got it? If I can't change my bases, so if I have an exponential function and I can't match my bases, I'm going to use logarithms. We good with that? Any questions? Okay. Let's talk about the other way. What if I have a logarithm equation? Okay, so this is review. We did this last lesson. Okay, we did this last lesson. So, say I have log base 5 of 4x minus 7 equals log base 5 of x plus 5. Remember, logarithm and exponentials are basically the same thing. If their bases were the same in exponentials, what did I do? I ignored them, right? I ignored them. So what do you think I do when my logarithm bases are the same? I'm going to ignore them, right? So if I have log base 5 of 4x minus 7 equals log base 5 of x plus 5, essentially ignore the logs, and I have 4x minus 7 equals to x plus 5. That's easy, right? Now what? There's no exponents here, so I just set so now just solve, right? So what am I going to do now? What am I going to do? Minus x, so I'll have what? 3x minus 7 equals 5. So 3x equals 12. And then x equals 4. Is everybody good with that? Okay, do me a favor. Try the next one just to make sure. Try the next one just to make sure on your own. I'll give you a minute. So ignore the bases because they're the same. 6x minus 12 Subtract 2x, so 8 equals 4x minus 12. 20 equals 4x. X equals 5. We good? Any questions? You should have one. What should be your question? What if the bases aren't the same, right? Because obviously in the last one, well, exponentials were real easy if the bases are the same, right? Just ignore them, set the exponents, solve. But then we had the problem is what if they weren't the same? So then I used logarithms, correct? So in this case, now I have logarithms, and my question is, well, what if the logarithm bases aren't the same? All right? Like for instance, this. Say I have log base 4 of 5x minus 1 equals 3. So this one's interesting because I don't even have a logarithm on the other side, right? So obviously they're not the same. The bases aren't the same because there's not even a logarithm there. Make sense? Ideas. You're smart. I know you are. Don't believe your parents. So wait a minute. If a logarithm doesn't have a base, it's 10, but there's not even a logarithm. You see what I'm saying? Okay, so Sam's saying, look, so then what if I take log 4? But remember, whatever you do to one side, you have to do to the other. So if you're going to put a log 4 over here, you're going to have to put another log 4 over here. I know you guys got this. So think about it. I had an exponential function, and I used a logarithm. Now I have a logarithm, and what do you think I'm going to do? I'm going to use an exponential. Remember, they're inverses. So it's like, how do you get rid of multiplication? You divide. Well, how do you get rid of division? You multiply. So for exponentials, how do you get rid of exponents? You take a logarithm. How do you get rid of logarithms? You're going to use an exponential. So the process is called exponentiate. Exponentiate. So exponentiate means you're going to raise the whole equation as an exponent to whatever base is needed. So, in order for you to solve logarithm equations, we're going to do what is called exponentiate. Exponentiate means I'm going to take the whole equation and I'm going to raise it as an exponent to whatever base I need. What base do you think I need in this case? A 4. Why? Well, because that's the base of my logarithm. Does that make sense? So, the way this looks is like this. 4 to the log base 4 of 5x minus 1 equals 4 to the third power. Did everybody see what I did? I took my equation and I made it the exponent of a base that I needed. Why would I do that? No, so they can, remember, your property number 4 from the last lesson said, if an exponent of a base and a logarithm have the same base, they cancel. So in this case, if these are the same, and they are the same because I made them the same, right? Because I made it that way for a reason. But remember, whatever I do to one side, I have to do, so that's why I did it to this side too. Does everybody see what I did? So now, what's going to happen here? So they're going to cancel, and I'm just going to be left with 5x minus 1 equals 2. Now, I don't want to leave it as 4 cubed because you can actually tell me what is 4 cubed. 4 times 4 is? Times 4 is 64. Now it's an algebra problem, solve for x. What do I do? So 5x equals 2. 65. X is equal to 13. So, how do you solve a logarithm equation? You exponentiate. You're using exponentials. Okay? And so does everybody see what I did and how I did it? Okay, last thing, you try it. Try it on your own. It's pretty much the exact same thing. I have log base 7 of 3x minus 2 equals 2. So the problem is I have a logarithm only on one side. So what am I going to do? What is that called again? Good. So what is it going to look like? Good. So just raise the whole equation as an exponent to whatever base you need. You realize what, right? You realize that this is whatever I want it to be. Correct? So then what's going to happen? And I'll be left with equals 49. Be very careful. And then, so 3x equals 51. X equals 17. I have a question. So, say I change this to natural log of 3x minus 2 equals 2. You can figure this out. So, over here it was log base 7, so I used the 7. Natural log has what base? So when I exponentiate, I would make it to the base e. Same thing. So that'll cancel. So the only difference here is this. See e squared? You can put that in the calculator, but you would be approximating, so I would tell you to leave it as e squared. Any questions? So like for this one, I would say add 2. So I would have 3x equals e squared plus 2. And then x is equal to e squared plus 2 divided by 3. I wouldn't. Maybe at the end if you wanted to, but not in the middle, just like before. We good? I'm sorry. Let me, one more thing. Any questions? We good? All right.